Hello, welcome, good morning. All right, here we go. Our first exam is next week. So it'd be good to get all caught up so you are ready for that exam, and we'll talk about that more later. All right, number one. First of all, we've introduced a new variable, which is the letter I, and I represents the square root of -1. Okay, so you're in junior high, you learned you cannot take the square root of a negative. The square root of a negative becomes imaginary. Roots are part of a parabola, but if it has an imaginary root, then it doesn't actually hit the x-axis, okay? Otherwise, the roots are the x-intercepts. We're going to talk about that later. Okay. Now, I can show you why. Yeah, if you want to see why that works. But it makes sense, right? That I equals I squared is -1. Yeah. So I equals I squared equals -1. If I multiply I times I squared, I get I cubed is negative I to the fourth is 1. When you come in to take your test, you need to have this down, written on your notes somewhere, right? Because this is going to help you out. Now, as we keep going, this does not have to be on your notes. But as we keep going, we see that I to the fifth is I. Oh, look, it's repeating. I to the sixth is -1. Repeating. I to the seventh is -I. Repeating. I to the eighth is 1. So if we were to continue this, we would notice that if I has an exponent that is the power of 4, okay, an exponent that is the power of 4, that's going to equal 1. Okay, so we want to look for the closest power of 4. Okay, so if we look at a multiplication table, I to the fourth will equal 1. Okay, Zoomers, I to the eighth will equal what, Zoomers? Mhm. Yeah, can you type into the chat, please? There we go. Thank you. I to the eighth will equal 1. I to the 12th will equal 1. I to the 16th will equal 1. So how do we know what exponent on an I makes it equal to 1? These are multiples of 4. Okay, so we're going to split this into a multiple of 4 and the leftovers, kind of like the square roots. Multiples of 4 and the leftovers. Okay, well, actually, I to the 24th is a multiple of 4. There are no leftovers. So if the exponent on the I is a multiple of 4, I to the 24th equals ding, 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 1. Okay, because the exponent is a multiple of 4. So I to the 24th equals 1. Yeah, are we good? Here, do you want to, did it come on?
Is it all lockdown browser?
Yeah, here, I'll do that part for you. Yes. All right. So let's go on to the next one. I to the 37th. Now there are multiple ways of doing this. There's one that uses a division and uses the decimals. There's one that uses a division and uses the remainder. But this is the way we're going to do it for right now. Okay, so I want the multiple of 4 that gets me the closest to 37. So we're going to have the multiple of 4 and the leftovers. So what multiple of 4 gets me, oh, sorry, not eliminate. Sorry. Can we go away? Okay, you start this and I will let you know when I'm ready for you to come grab this. Ooh, we're gonna have to restart. So I'm gonna need your password again. So just type in your password and then hand it to me and I'll do the rest. All right, so what is the highest multiple of 4 that gets us close to 37? Higher? What comes after 32? 32 plus 4 is 36. Yeah, 36. So 9 times 4 is 36. So we're focusing on the 36, not the 9. Okay, so we have I to the 36. Okay, so what would the leftovers be? If I have I to the 36, I know that I add those exponents. So 36 plus what equals 37? 1. Yeah. So anything, an I to the exponent that's a power of 4 equals 1. Now we look over here. I to the first power equals I. Yeah, I to the first power equals I. Done. Okay, so we find the biggest multiple of 4, and then we find out whatever the leftovers are. Okay. Now, number 3, do not do. Okay, number 3, do not do. Number 4, let's make a little table. Okay. Now, if ever the y value is 0, then these 4, 0 and -2, 0, I have found the what? If the y equals 0, okay, Cadence, it is ready for you. Thank you. Yeah, if the y value is 0, then 4 and -2 are the x-intercepts. Okay, so if the y value is 0, then I have the x-intercepts. If I knew that the x value was 0, I would have the y-intercepts. I do not have the y-intercepts. I just have a random point, 8, 10. Okay, so we're going to use the formula. We're going to use the x-intercept form of the equation. So we have a x minus, now it's on this formula sheet. What do we call them? We call them P and Q. Okay, that's not super common, but that's okay. We'll talk about that later. X minus P and X minus Q, where P and Q are the X intercepts. Okay, so y equals a x minus 4 and x minus negative 2. So I'm going to clean this up and then I'm going to think about how to use that 8 comma 10. So we have y equals a x minus 4 minus a negative is x plus 2. Okay. Now, what is my next step? How can I use 8 comma 10 to complete this problem?
I think we'll keep moving the Y.
All right. Oh, the y is, so I'm going to plug in x is equal to what? Yeah, what do you think, Zoomers? X is equal to, yeah, Zoomers? Eight. And y, I'm gonna plug in y is equal to what? 10. Yeah, so I'm gonna plug that in. So y equals 10. And x is 8. So clean that up. We have 4 and 10. Thank you. Okay, now why did I do this? WHY, not the letter Y. Why did I do this? The goal of plugging in X and Y is to find the value of what? A. Yeah, I need to find the value of A. So I'm going to divide by 40. A is equal to, and I'm going to leave it as a decimal, or you could say 1/4. So here's your equation. Y equals 1/4 x minus 4 and x plus 2. Notice the final equation has x, it has y, it has no other variables. Okay. Now, I don't know when this shows up. I know it shows up if you were to take the online exam. If I focus on these, if I have the 2 x-intercepts, how can I find the vertex? Where is the vertex in relationship to the 2 x-intercepts? Two x-intercepts, ding, 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 the middle. Yeah, yeah, do we see that the vertex can always be found in the middle of the x-intercepts? So to find the x value, I'm gonna average the 2 x-intercepts. So x is equal to 2 divided by 2 equals 1. Yeah, so the x value is 1. And then I could plug that in. So y is equal to 0.25, 1 minus 4, 1 plus 2, which is 0.25 times 3 times 3. So y is equal to 9/4. So if I wanted to find the vertex is x equals 1, y equals 9/4. That came out awkward. But the most important thing about the vertex, okay, Zoomers, I want everyone to type in. If I have unless you've already typed it in, if I have the two x-intercepts, where will I find the vertex? In the, yeah, Zoomers, ding, ding, ding. Thank you. Okay. Oh, I'm having flashbacks of last week when my OneNote stopped working. Okay, before we do number 5, I want to do number 16. Sorry, I need to fix this. Solve by completing the square. Okay, so solve by completing the square. First, we're going to have the order. I want my squared term. I want my linear term. I'm going to move the constant term to the right. So I'm going to add 43. Now, there's different ways to do this. Sometimes you move the constant, sometimes you just kind of leave it floating over there. So p squared plus 10p is equal to 51. Okay. Now I want to put this into a perfect square binomial. So I take the 10 and I divide it by, ding, 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 divide by 2. But if I were to make a box and foil that out, 5 squared, a 25 would appear here. That now leaves my equation unbalanced. To balance it, I need to add 25 here. So p plus 5 squared is equal to 76. Okay. Next, in order to simplify this, I need to get rid of the squared term. A square root will is the inverse of squared. We'll get rid of it. So p plus 5 is equal to plus or minus square root 76. And I'm going to subtract 5. P is equal to -5 plus or minus square root 76. Now, solving by completing the square. We're not going to talk about it much because people don't like it, and you can use quadratic formula instead of solving by completing the square. So people are like, nah. But this is not quite done. This did not get full credit. Can you see something, a next step we might need to take? Let's check the 76. Okay, so let's go to the chart of factors. and look at 76. Does 76 have any perfect square that's a factor? Any factors that are perfect squares? Is 2 a perfect square? No. 4 is a perfect square. Oh. Okay. So 76, let's do it over here, is 4, and the leftovers are 19. Yeah. So the square root of 4 is 2. The leftovers stay inside. -5 plus or minus 2 rad 19. Done. Okay. Now, completing the square. You guys, I promise, it is something the first time you look at, you just think, up above me, can't do that. Won't be able to do that. But with practice, it's not that bad. Now, some of them are really bad. If they have like fractions in them, they're really messy. Okay. Now let's talk about what happens if you're doing a problem and you're stuck and you look at photo math. Yeah. Is it horrible to use photo math to figure out how to do a problem? No. But if you looked at photo math, you need to do the problem again without peeking. Okay. Photo math is like having your own personal tutor at your house. But does the tutor just grab the paper and do the problem for you? No, you haven't learned. Do it again without peeking at photo math. Okay. So if you're stuck, peek. And if you look at photo math and you're like, what the heck? I have no idea what you're talking about. They may be using a crazy old-fashioned method because photo math is really a computer. They may be using a crazy old-fashioned method, and maybe we need to talk about it and say, hey, I'm stuck on this. Can you help me? All right. Now we're going to go back to this one. Now, number 5 will be on the in-person final as an extra credit problem. And you know me with extra credit, if you can get part the way there, you're going to get a few points. Okay, depending on how far you went. I mean, you need to do something. Okay, so this one will be extra credit on the in-person. So let's give it a try. Now, we're going to get this into the standard form of a circle. So okay, so what we're going to do is complete the square. So I'm going to move the constant term over to the other side. Now I'm going to put them in order. I'm going to put my X's together, leave a gap, then put my Y's, leave a gap, and have -196. Yeah, check my work. Did I make any mistakes? Did I leave anything out? Oh, in my other video, I left the 196. Yeah. Okay. So there's different ways to do this. So that method's a little tiny bit different. Okay. So we need to put this into perfect square binomials. Perfect square binomials. So this is going to be x plus what? What do I do to the 10 to bring it into the perfect square binomial? Ding, ding, ding. What do you think, Zoomers? What do I do? All right, divide by 2. So this is 5 But if I were to make a FOIL box, what would appear right there? 25, 5 squared. If 25 appears on that side, to keep it balanced, we need to add it to the other side. All right, y plus, okay, Zoomers, what number goes there? Okay, 14. Yeah, 28 divided by 2. But if that's the case, what is going to appear right here? Let me guess, you don't know. It is 196. Yeah, 14 squared. And if 196 appears on the left, you might want to keep that around. Oh, I thought you were like, no, she already told me I don't need it. If it appears on the left, we also have to add it to the right. So final answer, x plus 5 squared, y plus 14 squared is equal to, yeah, these cancel, right? Is equal to 25, which by the way is 5 squared, but that's okay. Okay, can you guys do that? Extra credit on the in-person exam? Sorry, not extra credit on the at-home exam because I don't know that you would be doing it on your own. So sorry, no extra credit. Okay, you do not have to do this one. If you do not know how to make a box to foil, ask me and we'll do it together at the end. Okay, let's factor this one. This is a diamond. Negative 21 goes on the top. 4 goes on the bottom. I am looking for two numbers that multiply to get negative 21 and add to get negative 4. We could check the chart of factors. Okay, so let's try it. -3 and +7. Yes, those give me -21. Will they give me a +4? Yes. I was really testing your confidence there, right? You're like, am I zoning? Yes. I know. Okay, so we have P -3 and P +7. Okay. Next, yikes, 225. Okay, I really hope I don't have to do rainbow diamond. Really, really hope I don't have to do rainbow diamond. What do you notice about the numbers 5, 70, and 225? What's my first step?
You are like divided by 5.
Ah, they can simplify, right? They can all be divided by 5. So we're going to divide by 5. This is GCF. So 5, and I have x squared minus 14x plus 40. 5? Let me just check. Yes. Yay! No more rainbow diamond. Yeah, I was able to pull the 5 out. So now let's just make a diamond. Two numbers that multiply to get 45 and add to get -14. Chart of factors. How about -9 and -5? Yeah, when you multiply, the negatives cancel. When you add, same sign sum. So this, we did GCF and then we did diamond. x minus 9, x minus 5. Okay, number 9. P to the 4th. I can't factor p to the 4th. Okay, step 1, GCF. They all have a factor of p squared. Okay, I can't get rid of the 7. I'm gonna have to do rainbow. So 25 times 7, 175. I need 2 numbers that multiply to get 175 and add to get negative 40. 175 is not on the chart of factors. So I know it's 175 times 1, 7 times 25. Can you think of anything else that would go into 175? How about 5? Yeah? Because I know if there's a 5 in 25, then 5 will work. So 175 divided by 5 is what? Oh, thank you. See that. Oh, 35. That's going to do it for us. Okay, so I have negative 5 and negative 35. Multiply to get 175 and add to get negative 40. Okay, because I did the rainbow, I must now do the square. I call it the box, but. Okay, notice I'm ignoring the p squared because that's outside. 7p squared, 25. Yeah, and the negative 40 splits into negative 35p and negative 5p. Okay, so GCF. The GCF factor, they both can be divided by 7p. 7p times p is 7p squared. 7p times negative 5. Negative 5. Negative 5 times negative 5 is 25. So we have p squared, 7p minus 5, p minus 5. Okay. Number 10 on your own, using the same methods that we just did. Okay, there's no GCF, but you're gonna go rainbow, diamond, box. Yeah, practice it. Okay, find the vertex and 2 other points. We're gonna make a table of 3 values. So vertex. Oh, first of all, what's the parent graph look like? Okay, exponent of 2 makes a U. Vertex. Now we could complete the square. Does anyone like completing the square? Nah. So what other method can we use to find the vertex? The X value is what, Zoomers? Thank you. Negative, right? Negative B over 2A. Okay, so X equals negative of -6 is +6 over 2 times 1, right? Because it was negative, change the sign to positive. So the X value is 3. If I know the X value is 3, I'm going to plug it in to get the Y value. Nine minus 18 plus 5 is -4. Okay, table of 3 values surrounding the vertex. So the X value of the vertex is 3, the Y is -4. 3, -4. There's the vertex. Okay, let's go. 1 to the left is +2, 1 to the right is +4. +2, +4. Let's get the Y values. So we're going to plug in 2 squared minus 6 times 2 plus 5. 4 minus 12 plus 5 is -3. Okay, now let's do it again with +4. You can just arrow up on your calculator and now replace the 2 with a 4. Yeah. So now we have 16 minus 24 plus 5 is -3. So 2 -3, 4 -3, and I missed a little bit, but there we go. Okay, so parent graph, vertex, table of 3 values. Do not do, but I'll tell you it is an upside down graph, right? Otherwise, same thing. So do not do number 12. Bunny problem. You need to be ready to do the bunny problem next week. And I think this one comes out decimals. Oh, no, it doesn't. Yay. I hate it when it comes out decimals. Okay, step 1, draw a sketch. Okay, existing building. Existing building is gray. Bunny pen. We're going to do bunny pen is purple. Now we call the width X. 60 total feet. We used X over here and X over here. Therefore, what is left for the length of the bunny pin? Ding, ding, ding. Yay, Zoomers. Yay. All right. 60 minus 2x. Good job. Okay. Area is y. So area is y, the width is x. So how do I find the area of a rectangle? Ooh, that's the next step. That's the max. The max is gonna give us the vertex. We're gonna go length times width. Yeah, it makes sense. That'll give us the area. And we want to maximize that area. So, and I know from past experiences, I'm gonna put it in standard form. Order. Okay, now, how do I find, and I notice there's a negative in front. This would graph an upside down parabola. Okay, so I need to find the width, which is x, that maximizes the area. Find the width that maximizes the area. Okay, so here's my graph. How can I find the max x value? I need to find the, okay, I'm gonna find the vertex, yeah. So the x value is negative b over 2a. Yeah, y equals negative 2x squared plus 60x. So equals negative 60 over 2 times 2, which is negative 60 over 4, which is negative 15. No, A is negative positive 15. Thank you. That's a negative. Okay, so the width that maximizes the area is 15. How can I find the max area? Okay, so I'm gonna plug in x is 15. So y is the area, negative 2 x squared plus 60. No, x is 15. Okay, which is okay, thank you. Y equals, oh yeah, there it is, 450. Yeah, plug it into the calculator. Yeah, bunny problem, getting better? Yeah, make sure you have notes when you come for your exam. It's gonna show up, guaranteed. Okay, how do we solve by factoring? First of all, put them in order, standard form. Add 10n and add 16. So up, thank you, equals 0, kind of looks like face. Okay, what's next? Solve the quadratic equation. Next step. Oh, nope, we just got everything on the same side. Starts with an F. Factor. Yeah, thank you. So I need two numbers that multiply to get 16 and add to get 10. How about 8 and 2? Okay, put in order. Factor. What's next? Starts with S. Split. N plus 8 equals 0, and plus 2 equals 0. The only way I can multiply two numbers to get 0 is one or both of them are 0. So, and solve. N is equal to -8 and -2. Yeah, not too bad. We're kind of doing a lot of review. Okay. Now, notice solve, you factor. Find all zeros or find all roots. You're still going to factor. So to find all zeros or find all roots, we replace the function or the y with a 0. Okay, so now f of x became a 0. What's my next step? Factor. Two numbers that multiply to get 10 and add to get 7.
Mhm.
5 and 2. Yeah. X plus 5, x plus 2. Now we're getting faster, so we're going to do split and solve together. X is equal to -5 and -2. Find the zeros, find the roots. Okay, solve by completing the square. Solve by taking square roots. This is a shortcut because there is no middle term. Yeah, there's no A. There's not an A right here, right? There's no A. So I'm going to isolate the squared term. Step 1, subtract 5. Okay, this one's messy. Next step, divide by -8. Okay. Equals or
Maybe it's like something
69 divided by 4. 69 over 4. Yeah. Now, the opposite of squared, the inverse of squared. How do I undo squaring? I do what to undo the squaring? All right, square root or square riot. Sorry. Sorry to laugh at your typo. It was just too tempting. Square root. Whenever you have x squared, you have 2 plus or minus. Now, what I'm going to do is I'm going to split 69 does not have a perfect square. No, 69 does not. Yay. We love numbers that don't need to be simplified. Okay, but 4, what's the square root of 4? Okay, so we have plus or minus the square root of 69 over 2. That needs to go away. Oh, no. Phew. Okay. Okay, quadratic formula. Yeah, we started this last week. Put in order. Plus 5x to both sides. And subtract 3. Now, this problem, if you did rainbow diamond box, you could factor it. But if it says quadratic formula, you have to use quadratic formula because quadratic formula is not that bad with practice. Okay. So quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So x is equal to -5 plus or minus the square root of b squared, 5 squared minus 4ac all over 2a. Okay, now this is not bad because you are using calculators. With your calculator, simplify that, please. And it's good to practice using the calculator. Careful, it's -3. Ding, ding, ding. Yeah, did you get 49? Okay. -5 plus or minus the square root of 49 over 4. What next? Okay, so square root of 49 is? Okay, -5 plus or minus 7 over 4. Okay, so now we have to split. So we have the plus and the minus. -5 plus 7 over 4 and negative 5 minus 7 over 4. Which is 2 over 4 and negative 12 over 4, which is 1/2 and negative 3. Now, quadratic formula is another thing that with practice, you are not going to think it's bad. Okay, it looks horrible the first couple times you do it, especially if you get real numbers. Okay. 19, we're not going to do. It comes out a square root. It's not that bad, but we're going to skip that for now. If you want to see it, we can do it at the end because it is way more complicated. Okay, 21, 20 and 21. I want you to look at those together. Are they the same? They look very similar. Okay, 20, what are we going to do?
Oh, isn't it the square?
Yes, that's right. Call it the square, I call it the box. Yeah, 21, what are we going to do? Okay, so 20, notice what is between them. Blank space, baby. Empty space. This is multiply. You make a box. Okay, this one is distribute and combine like terms. Okay, 3 minus 5i, negative 2 plus 5i. So we're going to multiply negative 6, 15i, positive 10i, and negative 25i squared. Okay, what next?
Should I take negative 25 and the I squared?
Okay, let's take a look. I equals I, right? I squared equals negative 1. I cubed equals negative I to the 4th equals 1. Okay, we've got I squared right here, right? I squared is negative 1. So this is negative 25 times negative 1 is 25. So now we combine like terms. Negative 2 plus 25 plus 10i plus 15i equals 23 plus 25i. Wait. Oh, that's not a 2. Sorry. It's a 6. 19 plus 25i. Okay, so 20. 21 is completely different. There is a minus between there. So I'm going to distribute. So I'm going to have 3 plus 6i. I'm going to distribute. That's going to give me positive 7 minus I. or plus negative I. So step 1, distribute. Step 2, combine like terms. Notice, no box. Yeah, no square, no box, because there's a subtract in the middle. 10 plus 5i. Okay, 24. Okay, so practice one more time, completing the square. And notice that's a minus. Yeah, and minus what? 19. But when you square it, what appears? Ding, ding, ding. 361. Okay. Now, you know what? We already did one. Yeah. I added it to the end and I forgot I already put one. We could do another example if you want. We are not doing these. Wait. Yeah, because they're very similar to 25 and 27. Now, sometimes you get, wait, these are different. I changed them. Okay. Sometimes you get one answer and sometimes you get two answers. So let's take a look. Okay, we did these last semester. Step 1, isolate your square root, add 10. Next step, to get rid of a square root, we square both sides. Okay, so 81 is equal to square root cancels a squared, 20x plus 1. Subtract 1. 80 is equal to 20x. Divide by 20. X is equal to 4. One answer. So sometimes you get one answer. Sometimes you get two answers, and sometimes you get two answers, but you check them and one of them doesn't work. So, and we're not doing that one because we already did an example of that. Okay, isolate your square root. It's already isolated. We are going to square both sides. Square root cancels the squared. Now, when I move the terms, I want my n squared to be positive. I'm not moving the n squared. I'm moving, because n squared is the king. I am moving the other terms. So I have 0 is equal to n squared plus n minus 12. Okay. Uh-oh, we have a quadratic that we need to solve. We're gonna factor, split, and solve. Yeah, invisible 1 right there. Two numbers that multiply to get negative 12 and add to get 1. Positive 4, negative 3. And plus 4 and minus 3. Okay, so 0 is equal to negative, not 0, sorry. Split and solve, n is equal to negative 4, positive 3. So with the square root problems, sometimes you get one answer, sometimes you get two, but you always need to plug them in and check. Let's plug in 3. 12 minus 3 and put a 3 over here. Square root of 9 equals 3. Square root of 9 is 3 equals 3. Check. The 3 checks. Yeah. Now let's plug in the negative 4. 12 minus negative 4 with a negative 4 on the other side. Twelve minus negative 4 is 16. Square root of 16 is only positive 4. So the only answer is n equals 3. But you got to show your work. You got to show your work that you got two answers. You plugged them both in, and only one of them is correct. For full credit, you need to show that whole stuff, that whole process. Yeah? Okay, look, it works over here, but you also plug it in over here, and the square root of 16 is not going to be negative 4. Now, why does very often one of them don't work? Because 4 times 4 is 16, negative 4 times negative 4 is 16, but when you're going the opposite way, it doesn't work backwards, it only works one direction. Does that make sense? But that's the reason why one of them ends up being canceled. Oh. Oh yeah, and we crossed off 30. We crossed off 29. Okay, that is it for today. Yeah, you are not going to do number 29 because we did one just like that earlier. So we are done. The only one I told you that you are doing on your own is, there was one, number 10.
Miss Ross, can we do number 23 together?
Oh, did I tell you to do that on your own?
I think so. I think we skipped it.
Oh my goodness. Okay, we're going to do 22 and 23. I crossed those off. I accidentally skipped those. Okay. Now, oh my gosh, I'm so glad you requested those. Okay, first of all, we need to know, what is the square root of x squared? What happens with a square root and a squared? They cancel and it comes out as x. Technically, it comes out as absolute value of x, but we're not gonna worry about that. Now, what about x to the 4th? So let's see. We have, that's x squared, right? Square root of x squared is x, and we have another x squared. So square root of x to the fourth is x squared. Do we see what's happening? It's cutting it in half. The square root cuts the exponent in half. Okay, so we have a perfect square, leftovers. Because it's even, it is also a perfect square. So square root of 36 is 6. Square root of a to the fourth is a squared. So we have 6a squared. Leftovers is red 2. Okay. 23. Eek. Let's see. 448. Okay. Let's take the perfect squares. 1, 2 squared is 4, 3 squared is 9. 4 squared is 16, 25, 36, 49, that's 7. 8 is 64, 9 is 81, 10 is 100. So we're going to take with the calculator 448, and we want to know which perfect square goes into it. So we're going to try 100. So 448 divided by 100, does it go in evenly or do we get a decimal? Okay. And 448 divided by 81. Decimal. And 448 divided by 64. Aha, okay. So we have 64 and 7. Now, k cubed. We have k squared and we have leftovers. Yeah, we have k squared and we have leftovers. The square root of k squared comes out as k by itself. Yeah, but then the leftovers go in. So what's the square root of 64?
8.
So we have 8k on the outside. Yeah, so this was outside and outside. And on the inside, you don't want to guess what we have on the inside? 7k. Okay, thank you for catching that. Now we're done.
I thought it was harder.
No, it's not too bad. The hardest part is figuring out what's the biggest perfect square. But if you make your list and you just divide working your way up, or what you're going to do is you're going to go to the chart of factors. You're going to go to your perfect squares and you're just going to divide, seeing which one goes in. The one that doesn't give you a decimal. Okay, now we are done. Any questions?
Yeah, I think that's it.
Okay, we're good. So, if you have a grade below 65% and you have to do remediation, you can type in that you attended the Zoom session and typed answers into the chat. And please get all caught up by the weekend because the test is coming up quickly
Oh, next week is the exam?
next week.